This is the story of how hunger built the human brain. Your brain costs more to run than any other organ in your body, and it only grew larger as our ancestors grew hungrier. For more than 2 million years, whenever food became harder to find, human skulls got bigger rather than smaller, and the reason behind that pattern is not what most people assume. Start with the basic problem. Your brain accounts for about 2% of your body weight, but it burns roughly 20% of your resting energy. That works out to around 500 calories every day, just sitting in your skull doing nothing visible. Other primates only spend 8 to 10% of their resting energy on their brains, which means humans burn through more than double that share. Newborn babies divert up to 60% of their total energy into building this organ, slowing physical growth for years just to keep growing ahead. In 1995, anthropologists Leslie Aiello and Peter Wheeler published a paper that gave this puzzle a name: the expensive tissue hypothesis. Their argument was simple. Brains and guts are both expensive to run, and you cannot afford both at maximum size. So as the hominin brain expanded, the gut had to shrink to make room. Shrinking a gut without starving meant upgrading the fuel, eating food that was denser, easier to digest, and packed more calories per bite. Hunger was the price of failing to upgrade. This is where the story turns technological. The first stone tools appear in the archaeological record about 2.6 million years ago, known as the Oldowan industry, which was a sharp flake knocked off a cobble in roughly 3 motions. By 1.7 million years ago, those simple flakes had evolved into Acheulean hand axes, teardrop blades that required around 50 separate strikes to make in the correct order, with a complete plan already in your head before the first blow landed. The point was practical. Tools cut meat off carcasses far faster than teeth ever could, and tools dug roots out of hard ground that would otherwise have stayed buried. Around 800,000 years ago, and possibly earlier, humans started controlling fire, with the unambiguous evidence coming from a site in Israel called Gesher Benot Yaakov. In 2009, Harvard primatologist Richard Wrangham published a book arguing that cooking did something even more important than warming the food. Cooking predigests it, and a cooked tuber releases more calories than a raw one with less metabolic effort. Wrangham wrote that we cook because we have to, that cooking is essential. For the first time in evolutionary history, an animal had outsourced part of its own digestion to a fire. Even with tools and fire, the food did not appear on its own. In the year 2000, anthropologists led by Hillard Kaplan published a paper in Evolutionary Anthropology asking what it actually takes to feed a brain like this one. Their answer came down to a lifetime of learning. Look at what a lifetime of learning means in practice. Among the Ache in Paraguay, peak hunting success is not reached until somewhere between 35 and 45 years of age. That kind of expertise takes most of a lifetime to build. Among the Hadza in Tanzania and the Yuhonzi in the Kalahari, successful foragers carry hundreds of plant identifications, track animals across kilometers by reading footprints and droppings, remember exactly where fruit trees stood from years before, and tell which mushrooms heal and which kill. All of that knowledge sits inside one expensive organ: the brain. A bigger brain is the only way to store that much survival data. Without it, we starve. Then there's the body. Humans have something called persistence hunting, where we chase prey for hours under a hot sun until the animal collapses from heat exhaustion. 2 million sweat glands let us shed heat that no other predator can match. Bushmen in the Kalahari still use this technique today on kudu antelopes. But persistence hunting needs route memory, weather reading, and pure patience, all brain-heavy skills. And the climate kept changing. Anthropologist Rick Potts at the Smithsonian calls his theory variability selection. Africa's weather swung wildly over the last few million years, drying out, getting wet, drying again, and the species that survived weren't the strongest. They were the most flexible. So a bigger brain pays off in 3 ways. It lets you make better tools, it lets you remember more, and it lets you adapt to whatever the planet throws at you next. All 3 were pushed by hunger. Now for the strange twist. Modern human brains are about 10% smaller than the brains of our ancestors from 20,000 years ago. Why? Once we figured out farming around 10,000 years ago, food became reliable. Stored grain meant survival didn't depend on remembering everything. And once you don't need the data, the brain stops growing. It shrinks. So the brain you're using to watch this video is the product of starvation, and might already be losing what hunger gave us. 2 million years. This is even possible. Round cobbles smacked, Acheulean hand axe, controlled fire, more calories than a raw one. Among the Ache, the Hadza in Tanzania, footprints and droppings, what hunger gave us.